Good morning or evening, afternoon, depending on when you're watching this. If you're taking a look at this sketch, you'll notice every time I click, I get a new one of these little wormy looking guys zipping around the screen. Daniel Schiffman calls this concept a random walk. So basically, as I click, I generate a new one of these little buddies, and they randomly zip around their original position, leaving a little trail behind them. And their color is based on their start position in this case. Now, this looks like a lot happening visually, and it might seem fairly complicated to create this sketch, but we're going to talk about how we can use parallel arrays to allow us to click all over the place and create as many of these little guys as we want on screen without having to hard code a variable for tracking, my random walk 1, random walk 2, random walker 3, and so on. All right, we are going to use arrays in place of individually naming them, so that we can have any number of them on the screen at any time. And you'll also notice this entire sketch in its current state is 29 lines, right? 29 or 30 lines long. So not bad. So let's get into how we can actually do this. Now, hopefully at this point you've seen my parallel arrays video where we simulate bubbles floating. There's going to be a lot of similarities here. So every little random walker is going to have an X and a Y value that tells us where he is at that moment on the screen. Now, we don't want to use a regular old variable like X or Y. We need to maintain, just like in the last video, an array of X's, right? And an array of Y's. So for every entry in the X's array, there's a corresponding entry in the Y's array. Those two together tell us where a single one of our random walkers is. I'm going to also make a variable called D that just tells us how big each of these is on screen. So we'll start that variable at, let's say, 10 pixels. And then a variable called velocity that tells us how quick they move from frame to frame. So we'll start by, let's set that equal to whatever our size of our random walkers is. Right. The main focus here is going to be these two parallel arrays. Those are the key to having an arbitrary number of random walkers appear on the screen. So let's go ahead and, just like we did last time, use the mouse pressed function to allow us to add to these parallel arrays every time I click on the canvas. So when I click on the canvas, I want to add to my X's array by using x's.push the coordinate of my mouse in the X direction, so my mouse X. Similarly, I'm going to add to my Y's array my mouse Y position at that moment in time. So wherever I click, the X and the Y are recorded together in these two parallel arrays for storing X's and Y's. So in the draw function, let's go ahead and start by just keeping an eye on our two parallel arrays. So we'll print out X's and we'll print out Y's. So let's go ahead and run that. Oh, and we'll also put a little spacer from frame to frame so we can just more easily see how this changes over time. So right now my X's and Y's are completely empty until I click. And then wherever I clicked was added. I just clicked at the point 6988. If I click over here, you'll notice that point is still maintained in the parallel arrays, but also the point 321, 328 is added. If I click up, in this top right corner, I get a value whose X is big because I was far to the right and whose Y is small. So it seems our parallel arrays, every time I click, are getting updated appropriately. That's awesome, right? At this point, I should have 4 little random walkers on my screen, but I haven't told the computer how to show them yet. And so we need to, let's go ahead and make our background look a little better. We'll change it to a bright white instead of this dark gray. We'll make our canvas just slightly bigger. And nothing has changed besides that about how the code is working. So just like last time, we need to loop over our set of parallel arrays. Now remember, parallel arrays means they're going to have the same length, because anytime I push to X's, I've got to also push to Y's. These things are happening in pairs. So when I look for the bounds of this for loop, I could use X's.length as my endpoint, or I could just as correctly use Y's.length. Right? I usually use whichever one I'm thinking about first, which for me is X because it sort of comes before Y in our coordinates. But X's.length is the same as Y's.length if we're doing our job correctly. So we want to go through there let's say we want to draw our little random walker using the square function. Now square, I've got to pass an x, a y, and a side length, right? Now side length, we're just going to use d, or diameter, or size, whatever you want to think of it as, the one I defined earlier. All of our random walkers are going to have the same size. It'd be a fun challenge for you following this video to change that. Instead of them all having the same size, maybe you do it like we did with bubbles, where you add a third parallel array called sizes, and I'll let you finish it from there. But we're going to use that same hard-coded size for all of them. But x and y are undefined. If I try to run this code right now, when I click, I should get an error. Oh, that's interesting. Weird that P5 doesn't report that as an error, but you'll notice it also doesn't do anything. It's just frozen, I suppose. Oh, we're never entering the loop. There it is. There's our error. And it's going to say x is not defined. And that's correct. X isn't defined. I never said what x is. So I need to define x, and we're going to go grab x out of our array full of x's. That's a great place to get one. So we're going to grab from x's at the current index in the loop, since we're looping over our array of x's. We can do the same exact thing for y's. So we're grabbing x's at 0 and y's at 0. Remember that those two match up to each other. For every x, there is a corresponding y at the same index. We don't need to define d because we did that up here in line 4. So if I run this now, everywhere I click, I get a little square because I'm adding to my x's and y's arrays. Now, these don't quite look like random walkers yet. Right? They're drawn with default fill and stroke, kind of boring. So let's go ahead and get rid of the stroke, and let's add a fill of an interesting color. Now, if you remember in P5, we can give an R, G, and a B value for red, green, and blue. Maybe we want to use our X and Y to determine how much red and green, and we'll just put some amount of blue in there. That's going to make our little squares show up in different colors depending on their XY coordinate, just for fun. Okay, I'm going to turn off the printing, but as you can see, every time I click, I get an X and a Y added. Now, how do I make these little guys randomly wander around the screen so that we actually have some motion? Well, you might be thinking their x and y need to change at random, and you're totally correct, but I can't just say my x is going to move by some random value, because if I do that, let's say we want our x to move some random value up to 10, right? If I run that, just like we saw in the bubble simulation, I don't get any motion because this x variable is temporary. It exists only for this iteration of the loop, and then it's thrown away. What I need to change is x's at I. That's my persistent array where I store the x values that I actually draw from to draw my shapes. So x's at I, we're going to say not random up to 10, but we're going to say we want it to be able to go up to velocity, whatever that we determined that to be up here, so that we can kind of tune that on our walkers. Now this is weird. When I click, I'm getting some motion, but they're exclusively moving to the right. Well, that's because I'm picking a random positive number and adding it to my x. I need that to sometimes be negative as well so that I get them moving back and forth. The nice thing is I can say random between negative velocity and positive velocity. And now I'll see my little random walkers wiggle back and forth only in the x direction because that's all I've specified. So it looks like we might need to tune our velocity down a little bit. They're kind of seizure-inducing how fast they're moving. But let's go ahead and do the same for our y's. Y's at I is going to move, it's going to get added or subtracted some random value within our velocity range. And so these are really shaky, so I'm going to go tune the velocity to say it's not as big as d, maybe it's half of the size of the thing. That looks pretty good. Another way we could do it is to say, instead of times 0.5, let's go even smaller, times 0.3. Now we've got random walkers who are kind of jiggling in space. They move gradually over time, but they generally don't take a straight path to get anywhere. The only thing missing here, and if we turn back on printing, let's take a look at what's actually happening in those parallel arrays. If I add 1, you'll notice every frame x and y for that one random walker are updated by a little bit. They generally stay in the same area. He's not jumping from 0 to 400, but they're changing every frame. If I add a second one, you'll notice I now have 2 x's and 2 y's both changing every frame under the hood. So how do we get our random walkers to leave a little trail like they did? There are several ways we could do this. What I think is the easiest way is to actually forego this background call, right? We can get rid of that because background for some reason doesn't allow us to specify an opacity. So instead, right, we're going to say we want to draw a rectangle at 0, 0 that is width wide and height tall. That's going to cover the entire canvas. Now you'll notice this is kind of freaking out because our fill is changing inside the loop, so we're getting random fills, not random, here. So we want to fill with white and draw it, but now we've just taken a roundabout way of drawing the background. What I want to do is give a second argument that's our opacity. So 0 would mean 0, completely transparent, there's no point in drawing this. If we were to draw it at 255, it would be the exact same, that's full opacity. We want somewhere in between, so let's look at 100. Now you'll see from frame to frame, we see sort of a transparency of the background drawn so that our random walker's old positions slowly get overwritten. So if we were to make this all the way down to 0, you'll see we get a complete trail. It never gets overwritten, right? And if you've seen what it looks like at 255. So you can kind of tune this second number. The smaller the number is, the longer tail that each random walker is going to leave. So I think it looks nice right around 10. You might have a different opinion, and that's fine. So the last thing I might change is go back and change the diameter of these, see if I like it better at a smaller diameter. I think right about 7 is a sweet spot for me personally. But now you can see every time I click, a new random walker is generated. In this case, if we get rid of our print statements, again, we're looking at right about 30 lines of code. Not a ton of code, but some pretty interesting performance we're able to get using this awesome little parallel arrays technique. When you're using parallel arrays, just remember, right, you declare them together. When you push to one parallel array, you better push to the other. If you are removing from them, the same applies. And then when you go and grab from one parallel array, you're probably going to grab from the other. And again, if we want something to change and it's being directed by parallel arrays, you need to change the value in the array, not the value you pulled out of the array, if that makes sense. So a really good challenge if you followed along with this video and your code is working, but you're thinking you maybe understand it, maybe don't, go change this, add a third parallel array called sizes, and give every random walker a random size. Right? Maybe you can make their velocity depend on their size too, but that would be my challenge to you, is to go make their size generated, at the time you click, and then that size is persistent, but random from walker to walker. I hope this has helped. Thank you.